Okay, so with this video, I'm reviewing some of the newer ideas in the psychology of reasoning, the associative heuristic network and its relationship to analysis and reasoning. Well, reasoning is typically measured by tasks which assess what's known as fluid intelligence. Often they involve the matrix type problems that provide us the elements with a complete set of information, and they ask us for that basically require us to find a certain pattern or relationship between those elements. So there is no novelty involved in selecting the set of elements. The elements of the set are already there. They're already chosen. They're provided for you. It's just a problem that requires analysis. But what if the set provided was partial and incomplete, and the relevant elements were scattered through time and through different in different positions in space, much like complicated problems in the real world, with the relevant information spread through different fields and different domains. With a small set, it's fairly easy just to eyeball the elements, and by trial and error, you can just bring the right elements together. So anyone can really find a subset which contains a meaningful relationship. But from a larger superset, it's statistically rare to select elements by chance to form a related set. So we need a way to relate ideas in a way which doesn't rely on the way nature has presented the elements to us. The associative heuristic network, it's a pre-analytic process that utilizes features, so it's called feature-based induction, to kind of bring together the elements of a set. So what it basically does is it's a search and target. It does search and target, and elements that are structurally, statistically relevant to a presented stimuli. And then it aligns. It brings them together and aligns them in some combination or some permutation for being analyzed. So our brains, I guess, are constantly and almost subconsciously registering associations through associative and implicit thought. So a higher associative memory basically results in a kind of a more richer and more interconnected network of ideas that are related more subtly and through statistically inconspicuous relationships, while a poor associative memory results in a bland network that reflects only superficial relationships. So imagine a set of infinite size and spanning through the vast dimension of time. So you can consider such a set to represent our experience in the real world. In such a superset, some subsets will be complete with their elements in contiguity, so they'll be right next to each other, and it just relies on analysis to establish new ideas. But some of these elements are in partial sets, with the related elements being presented sometime in the past, or maybe being presented sometime in the future. So as we examine this superset, the associative heuristic processes begin. And individuals with a higher associative depth, might enjoy better performance because they're able to relate ideas more effectively. And time flows, so if connections are not created in time, then they're quite often lost to time. If you didn't notice, someone in the store looked like a childhood friend, then you might never know if he was indeed. And you might not be able to make sense of connections which aren't created in some type of temporal order. So in real time, it's important to register information in time. But even for fluid reasoning, without time limits, with no time limits, it seems that there's basically a relevance with associative memory and relational learning. So they contribute to fluid intelligence under untimed conditions. So basically, in a recent study by Adam Chuderski, he showed that he basically decreased the contribution of working memory to fluid intelligence from 1 in a speeded test to 0.38 under lightly timed conditions. So even for analysis, factors like associative and relational learning would be important under untimed tests. And beyond that, it's quite likely that it's just the adaptive efficiency of long-term memory, short coding, becomes a factor in performance.